All right, we are live. Excuse the delay. Keeping it real, I am rusty. We have not done a Work It Out Wednesday since the holidays, but we are back and we will be here through final exams in May. We got some good stuff cooking and in store for you. We know state testing is coming soon, so we're going to offer some days where we work the previous test out and show you all the different misconceptions. Thank you for joining us this evening. And in a minute, I am going to get kicked off with starting to work some problems. I'm just going to give everybody a minute to join us right now. Yes, welcome to our live. Welcome back. Welcome back. Welcome back. Welcome back. So I'm just going to go ahead and jump right in. And we're going to start with a oldie but goodie. This is for your second grader, maybe even your first grader has started these, and we call it the break apart method. And this is actually one of our sheets that we do here. And I like to tell all my students, let's first break apart using place value. So we have 24 minus 17. So we know that we can break this apart into 20 and 4 into 10 and 7. Alrighty, so we can do our first ones. Just realized this. Alrighty. So we are going to add to get back to what we are looking for. Let me see. I need to start over. I broke this apart incorrectly. Do I have another one? Because we are using addition. Let me just go here. Alrighty, so I'm gonna do that problem again, just a different way, because I didn't know this. So we're gonna do 24 minus 17, and we're going to do our break it apart here. We're going to make that a 20 and a 4. We're going to make this a 10 and a 7 for right now. And so first we're going to start off by doing our 10s. 20 minus 10 is equal to 10. Alrighty. Then now we have our ones that we are going to subtract by each other. And what we can do here to make this simpler, we can do our 7 minus our 4 is equal to 3. And then we can add those together to get 13. Hopefully you can see that. And this is the simpler way to use the break apart method to do subtraction. You're just really focusing on your 10s and your 1s as you do this. We're going to keep going this evening.
Hold on 1 second. Yeah.
So we have been working with our older students lately, and we have been working on solving equations and inequalities. And so tonight I am going to walk us through solving a one-step inequality. So we have 25 is greater than or equal to negative 2x minus 9. And everything we have been working on is to get our students ready for their state exams here in Texas, and everywhere should honestly be preparing for their state exams. So let's get into this one. We really focus on the steps, and I have this anchor chart here that goes over the steps for solving inequalities. First, you add or subtract the same values for both sides. Then you combine like terms. So let's first do that. So we want to look at when it says combine like terms. I always tell my students that they can circle the ones with the variables. They can box their consonants. And why do we do this? Because we know the same shapes, that means they're the same, and those are the ones that we are going to have to put together. So since we have a minus 9, we're going to add 9 to both sides. Negative 4. You get 34 is greater than or equal to negative 2x. Then it says that we are going to divide by the coefficient in front of the variable. So now we are going to, our coefficient is a negative 2. So we're going to divide both sides by a negative 2. And so something happens here. If the coefficient is negative, we have to flip the sign. And so our coefficient here was a negative 2. So we are going to actually have to flip that sign. This side, that becomes a 1, so they cancel. And then a negative 2 is really just what's half of 34. And we get 17 negative, because our 2 has a negative, and it equals x. So negative 17 is less than or equal to x. And we are also going to graph this. Inequalities absolutely trip our kids up because they actually understand how to solve the equation. It's when they see our symbols of less than, greater than, or equal to that they start to not understand, as well as when they have to flip. That's movement, and that's making sure you're understanding that you're multiplying or dividing by that negative number, as well as we are graphing on a number line. So since this is negative 17 is less than or equal to x, we can graph that as well. And some of the rules we might be rusty on is because it has an equal to, that means we're actually going to have a closed circle at negative 17. And since it said less than or equal to, we're going to be counting down here. And then we were going to just draw. And I'm going to make that. So that would be the solution to our inequality if they had to graph it as well. And so let's work another problem that we have found that our students have had a little trouble with. So we have 4 plus 1/2 x minus 8 equals 12. Alrighty. I will tell you, so many of our students struggle with this right here. This 1/2 x is such a huge struggle. And I say that because in this particular problem, we can actually do it 2 ways. And tonight I will show you both ways. I will show you 2 ways that we can do the problem. We can solve it like we do the regular steps of the equation. So first, we're going to add or subtract the same values from both terms. We're going to combine the like terms, and we're going to divide by the coefficient in front of the variables. So first, you see, we're going to do what I said before. We're going to box what's the same, and we can circle what's different, box what's the same. So to make it easier, I am going to first combine what's on this side. So 4 minus 8 will give us a minus 4 plus a 1/2 x equals 12. And then we are looking to get our constants on the same side. So we are going to add 4 to both sides. So now we have 1/2 x is equal to 16. Well, the thing about this fraction here, we can do the reciprocal, which is this fraction flipped. So it becomes 2/1, which is the reciprocal. And why does this work? Because we know we multiply fractions across. So 2 times 1 is 2. 1 times 2 is 2. And what does that equal? That equals 1. And we know that when we have an x, we just represent 1 as the x by itself. So now what we do to one side, we do to the other. So on this side, we will also multiply by 2/1 times 16. And so just like our reciprocal here, we tell our students there's always an imaginary 1 underneath our whole numbers. So we can actually put an imaginary 1 under the 16, and we're going to multiply across because that's what we do with fractions. So 16 times 2 is 32. And with our 1 underneath, it will just be 32. So our problem is x. Our solution is x equals 32. That really gets a lot of students tricked up because we are utilizing the reciprocal. Another way, and that's if they see it, but we have to really focus in on teaching them the reciprocal. Some know that if you're multiplying by a 2 on top and you have a 2 on bottom, they would cancel out to give you that 1 as well. So that is another way we can work it. Now, I'm going to show one more way we can work this same problem. Alrighty. So we're going to work the same problem, but this time we're going to pretend they gave us some answer choices. Oh, that was supposed to be a C. But we're just rolling with the punches. My mind was thinking faster than I could write. Okay, so this time I really want to show you what happens when we're making our students multiply this 1/2 plug and chug. So if you're already given the answer choices for x, what x equals, Your student can easily plug it in. What we have found is a lot of our students struggle multiplying a number by that 1/2. So for instance, here we do 4 plus 1/2. Let's do times 8 equals 12. So, and I left off our minus 8. So everybody's comfortable when we have to do the 4 minus 8 becoming a minus 4. But all of my students shied away from this right here. And why is that? Because they're like, what do I do? A lot of them didn't realize you're multiplying. Some made this addition. Some kind of skipped over it altogether. It's very interesting what we got. But the same way we multiplied the other whole number, you treat this whole number, you have your imaginary 1, and you're just multiplying straight across. So we get 8 over 2. And we would have our negative 4 equals 12. And so, say you didn't want to deal with this 2. We know that with fractions, it's related to division. So this is really meaning that 2 is dividing into 8, or we're breaking that up. Or you could even multiply this whole equation by 2, and you can cancel out this 2 on the bottom. So you have options to make it something that you might be more comfortable with. So I'm just going to multiply by 2 just for kicks and giggles here. So we would get a negative 8. And then for here, we would cancel that. So then this would be a plus 8 equals 24. When you do a move like this to cancel out your fractions, you must multiply by the whole equation. So everything is still in proportion to what you originally started. So many. Absolutely. There's always a lot of options. It always depends just on the student, their understanding, where they are. And honestly, teaching students different ways is allowing them to challenge themselves as well. Well, we know negative 8 plus 8 is 0. So that wouldn't have been the correct answer choice. But on a test, basically, a student, if they already have the answer choices, they can plug this in instead of working it the way we did the first time to discover their answer. But they have to make sure they understand how to multiply a fraction times a whole number with comfort. Alrighty, let's move on to something our younger babies are doing tonight. And so right now, I say it is word problem season. It is word problem season. So everything is about word problems, critical thinking, and problem solving.
And you got a request.
Oh, what's the request?
It's on the screen. Hey guys.
Okay. Let's see. Can you explain why the problems answer before this one was 13? Okay, let me see what we're talking about. Okay, so let me see. Okay, so our first problem of the 24 minus 17. Let me see why we did get 13, actually. What did I go over there and do? I can't do that. Okay, let me roll it back. I see what the person is talking about. Is Miss Tiana still with us? Let me go back. I think I was moving too fast because I'm looking back at what I did. So she is talking about 24 minus 17 using the break apart method. So when we break apart, we're actually using our place value, right? So we have our ones place and our tens place. And I like to get my students to label so we remember. So we have 10 and 7. We have 20 and 4. So I am going to start off by doing 20 minus 10, which gives us 10. So that takes that out. And then what we actually can do is 10 minus 7 now, which gives us 3. And then last step, we're going to take this 3 because we have this 4 left over plus 4, and we get 7. So actually that answer was 7. And thank you for catching my mind going too fast and not looking at the steps. Sometimes when you're used to higher level math and you see those easy problems, you just go so fast that you didn't look at what you were doing. That's me. But that's the other step. So I'm a very visual person. So how you saw me when I used one of the numbers in the break apart, I canceled it out. So we used 20, we used 10, we got 10. And our babies, they usually know their tens, 10 minus 7, 10 minus 5, 10 minus anything. So then now we did 10 minus 7, we got our 3. And since we had that 4 left over, that's when we come to our addition and we get 7. I hope that answered the question that we had from Tiana Simon. I appreciate you. All righty. And let me know in the chat if y'all want to see another one like that break apart. I do not mind doing another one. Somebody saying something. As I was headed to something else. Kimberly, did we have anything else? Anybody say anything that I need to look at? We're all good. All right. So we're still sticking, which that was perfect. That keeps us leading into, you are welcome, Tiana. We are leading into some more elementary problems tonight. And I'm going to just pick one. It looks like we have a little variety here. But like we said, this is problem solving time. So everything is about word problems and our students identifying what questions are asking us and thinking critically, as well as I tell kids, let's model, let's draw some pictures. This is a great time to make our word problem stories because that is all what they are. And there's such a deep connection between math and literacy. And word problems really remind us of that. So let's take a look. We're going to do maybe the first two on this page. Lasagna. Let me see if y'all can see it a little better. There we go. Lasagna earns $50 each month for completing chores. How much allowance does Lasagna earn in 7 months? So we know we have $50 each month, and we want to know how much she earns in 7 months. Well, we know we're really multiplying here. So we're really doing 50 times 7. And for most students, they are going to know their 5 times tables. So a lot might know that 5 times 7 is 35 and that we can add our 0 behind it. But for some of our students who they still might be struggling with their multiplication facts, which is actually quite a few of our students we've learned, they might want to draw a picture. So if we draw 7 pieces here and put in our 50, 50, 50, 50, 50, 50, and 50. And luckily it's 50 because most students will know 2 50s make 100, right? So we could quickly add those together. And that's easy for a student. 100, 200, 300, 350. And so Yes, we have students that struggle with their multiplications, so we have to show them how can you make a visual. And in this visual, while 50 was easy, say this was 40 and they maybe weren't sure, right? They could just add. They could add 40 and 40. That's something that they might be comfortable with to get their 80 and then add as they go to get their whole number. And yes, our students do have to do those extra steps these days. And that's why it's so important that we are working on our basic skills with our students daily if we can, so that they do know these multiplication in the future. All righty. A chemist has 5 test tube racks. Each rack holds 44 test tubes. What is the total number of test tubes these racks are holding? So a chemist has 5 test tube racks. So I might just draw. I'm just going to draw 5 test tubes, honestly. Maybe not the racks. Each rack holds 44. And doing this visually also is a great way to show your students that what multiplication is repeat addition, right? We tell them that, but this visual gives it. So now we can absolutely do 44 times 5 here. We get 20. So we get 220. Now, us old school folks, we used to have to grid. The new school kiddos, they're on the computer. I don't think they're gridding too much these days. So you don't have to, teach them to make sure to grid a certain way and to bubble in hard anymore. So I'll leave us to the old school folks for that, for sure. But practicing word problems and your multiplication facts with our students is really great. I would definitely say if you have a 3rd grader, if you have a 4th grader, or a 5th grader, this is perfect work for them. This is great practice, visuals, word problems, and multiplying. They need this. And truth be told, our 6th, 7th, and 8th graders, this could be great practice for them too, because a lot of them don't know their facts these days. Kim, do we have any questions, comments, concerns, problem requests that I need to know about right now? Just give me a wave, a thumbs up, or something. I can't even see it right now. What did you give me? Thumbs up, meaning no request. Where's the number 2 pencil? What? I like my marker. Crayola. I like my Crayola marker. Let them know so they come sponsor me. No, I do work in pencil, but I just like the marker here for visuals, for sure. I'm deciding what age level should we go to next for problems. Alrighty. I'm just going to head to another go-to strategy for our younger group, and I might do these too. So it is using an empty number line. And it's so important we say that, an empty number line, because unlike maybe a number line where you do like you're counting 0, 1, 2, 3, when you do an empty number line, you have options. That's why it's empty. So you can do something like this, where maybe I start at 75. And because I know I'm trying to get to 25, or I'm taking away 25, I'm going to do it like this. I know that means that's 2 10s, right? So I'm going to draw one hump, and this is going to be take away 10. So that is 65. I'm going to draw another hump, and I'm going to take away 10. That's 55. And then now I know I have a 5 in my one place. So I'm going to do a small hump just for kicks and giggles. I'm going to take away to 50. And so this is a way that you can use an empty number line where you're actually taking away based on the number. So that's one way that we can do this and use the empty number line to get to our answer of 50. Now, this was your baby's go-to method last year? Okay. I'm going to do a different way this time. And instead of taking away to get to it, we are going to use it to get down to 35. So, say we are at 67. All right. We are at 67 this time. And we're going to ask ourselves, wait, am I saying something? No. Okay, yeah. We're at 67. And so I want to get to, I know, 35, right? So we're going to go 10, that's 57. We're going to go another 10, that's 47. We're going to go another 10, that's 37. And so once I'm at 37, I know we have 36. We have 35. Now we're going to go back. That was plus one jump, plus 10, plus 10, plus 10. I probably should have wrote those numbers inside the humps, huh, y'all? You see, this is just on the go. So now where our answer would lie is actually here. The jumps that it took to get from 67 to 35. So that's 10, 20, 30, 31, 32. And if you were wondering, yes, this can absolutely work for larger digits. You can do high digits, 1,000 if you wanted to. It always works the same way. The biggest thing you have to worry about with your students is just spacing and them figuring out the spacing for sure. So this will be our last problem that I'm going to do tonight. And then we're actually switching over to TikTok, where we will be working out some more problems this evening, courtesy of Hilltop University. If you would like to join us there, you are more than welcome. So we're going to do it the way that we just did on the last problem to get everybody more comfortable. So we're at 234. And so we're trying to get to 126. So I'm going to go down to 134. All righty. Then we're going to go down. Oh, I should have made my hump so big. Go down to 100 and that'll be too low if I go to 124. So let's go to, let's do 5. That's a good one. Okay, so let's go by 5 then. So we will be at 129. Or actually, the student could have also, so let me, so I can remind myself, we're doing 5. We did 100. They could also go down by ones at this point too, if they weren't sure what the difference between 5 and 134 is. So then we're at 128, 127, 126. And so there's our plus ones. So we have 100, and then we have 5, 6, 7, 8. So that is 108. And that would be our answer. I like the empty number line method. There are many, many ways that you can utilize it, from starting with the number, getting to the number you're subtracting, as well as starting from the number and taking the actual difference of the number that you are getting. Thank you for joining us tonight. We will be back next Wednesday. Feel free to email us your problems. I would love to do your problems live and hear your questions. You can always email help@mathematicstutoring.com, and we will be happy to assist. And just remember, we also do private tutoring. If you are shy, or if you have a student that needs one-on-one support, we do one-on-one tutoring. If you liked any of the strategies I shared tonight, or the anchor charts I shared, we do have those available as well for sale. Thank you so much for joining us, and have a great evening. Goodbye.
Bye, guys.